Hello, welcome back to Cracking the Cryptic, and a puzzle by Truffle Bear today. Now, I didn't check whether Truffle Bear's featured on the channel before. Not often, if so, but if not, welcome, Truffle Bear. I do like the title, Pining for the Fjords. It's clearly talking about the Monty Python Dead Parrot sketch, which I found hilarious all my life. I could quote large parts of it at one point, probably couldn't now. I do also know that a lot of people believe that a Norwegian blue is a real parrot species, which is absurd. In fact, maybe that is where the title comes from here. The collocation of a parrot, which is a bird from a hot climate, in the fjords of Norway, which is a cold climate. Because this puzzle is all about hots and colds and yin and yang, and we'll do the rules in a minute. But first of all, don't forget that on Patreon now we have the Hollywood Lunchbox collection of sandwich puzzles. Give them a try. They are unusual in many respects. Some are quite difficult, some are not so difficult. So a real collection to test your mettle. And 7 puzzles there. Give it a try. You do have to do each puzzle in order, so there's no skipping ahead this time in theory. Although I don't know, in practice you might actually be able to work backwards in some ways. It's an interesting collection anyway, and one for movie buffs too. Now, what else we got going on? We've got all of, I mean, there's other stuff on Patreon as well, but we've got all of our apps, and those are on the links under the video, including Killer Sudoku and Thermo Sudoku. No hot and cold Sudoku yet, but Approachable Sudoku is our latest, and it's proving very popular. Do check them out. Along with Sven Sudoku Pad and our merchandise. And the first link under the video is to this puzzle, Pining for the Fjords. He's pining for the fjords. By Truffle Bear. So I'm going to do the rules. Normal Sudoku rules apply. So that's going to mean 1 to 9 in every row, every column, and every 3x3 box. Now, this is basically a map, this grid, the map of a peninsula with cells being either land or water. 3 sides of the map are completely water. Well, that could be those 3 sides, say. And the 4th has a land connection of a width to be determined to the off-map mainland. All the land cells are orthogonally connected, as are all the water cells, and no 2x2 area is either all land or all water. And if you have followed us on the channel, you will know that those are basically yin-yang rules. I'm going to probably make land orange and water blue. All the blue cells are connected in one lump together, but with no 2x2s. Same for all the orange cells. Digits within cages don't repeat. Now, the number shown in the cage is equal to the sum of the digits in the land cells minus the sum of the digits in the water cells. So in this -8 cage, the total of the water cells is 8 more than the total of the land cells. The water cells are minus, the land cells are plus. Simple enough, actually. Digits on a thermometer, not values. Digits on a thermometer strictly increase from the bulb end. Due to the rocky shoreline, transfers between land and water are not easy. So when a thermometer's cells switch from one to t'other, as the original rules said, the value must increase by a minimum of 2. Okay, so the normal rule along a thermometer is that values go up by at least 1 each time. Here, if we change from blue to orange or orange to blue, they must go up by at least 2. That's it. It's not a complicated rule set if you've ever seen yin-yang before. That bit's maybe a little harder than usual. But it sounds fascinating. I'm always happy with a map puzzle. Let's give it a try and say, oh, let's get cracking. So, with a yin-yang puzzle, you know about the perimeter. In fact, we've been told more about the perimeter than usual here, but you always know about the perimeter that it's divided into no more than 2 strings of colour. One colour and then the other colour, because if you tried to join 2 different strings of one colour, you'd cut off the 2 strings of the other colour. You don't even need to know all that this time, because it's been quite explicit. There are 3 sides that are fully water, and one land bridge, basically, of an unknown length. So we can make all the corner cells water, because whichever 3 sides are fully water, it'll take in those. Now, there's a 5 cage in the corner here. 5 is not a big enough number. Well, we already know there's a negative cell in it, but we know from the fact that 5 is positive that there's a positive cell in it. And therefore, one of these 2 cells is positive and is part of the land bridge, and the 2 sides that don't include that are clearly not part of the land bridge. Now, we can even go up here and avoid a 2 by 2 by putting a positive digit into a -8 cage. Now, does that mean we can make the other 2 negatives? Yes, I think it does. Whatever you put in, if you had 2 positives, the biggest negative you could have is -9. The 2 positives would be a 1 and a 2. That would only get you to -6. So these are both negative. This land has to get out, so we can colour those. And we've made a real start already. I was going to go and do a bit more thinking about this 5 cage, but I don't know. One of those is orange. The other must be blue because the other side will be fully blue. I don't really know what to do about that. So let's go up here where we've got this start. That's orange to avoid a 2 by 2. And this is a -20 cage, which has got all the cells of this thermo in it. Now, how are you going to get to -20 with only 2 negatives? You couldn't. They would only add to -17. So 3 of these are negative. I know it's not all 4 because I'm not allowed a 2 by 2 all in blue. Not trying to make a rhyme here. It happens all the time here. So 3 of these are negative, are blue, and 1 is positive and is orange. Do I know which way round they go? I'll tell you something else about yin-yang is that you can never have a checkerboard in a 2 by 2. Now, what do I mean by that? I'll just show you. In this 2 by 2, you could never have those 2 being negative and those 2 being positive, because you couldn't connect the positives without cutting off one of the negatives, and vice versa. So that's something we might be bearing in mind even more than the perimeter facts. Okay, as well as that 20 cage, -20 cage, we've got a -20 cage down here and a -23 cage. And again, for exactly the same reasons, they've got to be 3 blues and 1 orange each. Okay, this can't be the orange in this cage because it would get cut off by the blues. The fact that this has got 3 blues in it makes me think this is the blue side that we still have left to find. I don't know. It's not. It's not enough. Right, can this be negative? Let's think about that. Actually, it can. If that was a -1 and this was a +7 and 8, the sum would be right, and that could be a 9. Okay, so let's try the 20 cage again. I'm just while I'm thinking, there's a 2 cage and a -2 cage, both of 2 digits. I'm sure that both of those are a domino, 1 of each colour, because you couldn't make them up with the same colour. You'd have to have 1s in whatever positivity you were talking about. And that would cause a Sudoku clash. Maybe it is indeed Sudoku that we need to think about. Right, so let's add up the numbers that go into the 20 cage. Oh, remember that rule. When we change parity colour, or positivity colour, we have to jump by 2. Right, the higher digits in this are surely all going to be negative. That is something I believe, because if you took, if you took the highest digit as negative, if you took the highest digit as positive, 9, you can't get, the three negatives can only add up to 21, 22, 23 or 24, leaving the single positive to be 1, 2, 3 or 4. It can't be 1 because it's not the first digit on a thermo. So is the positive here or is it here? The positive is 2, 3 or 4. If it is 4, the negatives are 7, 8, 9. If the positive is 3, the negatives are 6, 8, 9. If the positive is 2, the negatives add up to 22 and they must use higher digits. So the lowest digit is the positive, the other three are negative, and we get this shape. Right, now this is blue to avoid a checkerboard. This is orange because orange has to get out. Orange has to get out at the top as well. And now we've got 3 cells here that are all positive. So if that was a 1, oh, and remember the jump when we go to land. Yes, at the absolute minimum, this cage goes 1, 3, 4, and then jump 6, 7. And that's the 14 we need. So I've got some digits now. 1, 3, 4, 6, 7. This is 8 or 9. It could be 8 if it's land, but it could be 9, whatever colour it is. Putting digits in suddenly makes it harder for me to see the patterns. Never mind. Now, anyway, we got to start. Did we work? This was 2, 3 or 4. That's 1, 2 or 3. These are, they definitely include a 9 because they add up to at least 22. This can't be a 6, so they add up to at least 22. That is 7 or 8. This one could be as few as 5, I reckon. It can't actually be a 7 because of Sudoku. Good. Do come in, Sudoku, and help out. Now, so it either goes, well, now it can't go 4, 7, 8, 9. So that's not a 4. That's 2 or 3. This is 1 or 2. The jump has been achieved, whatever happens here. Right, okay, what about this cage? It's got 2 negatives and a positive that is at least 2. The 2 negatives add up to at least 10. Okay, I don't know. The trouble is this is now making me look at areas of the map that I hadn't been getting anywhere with when I looked at them earlier. Okay, this is now 1 of each. Do we know which way round that is? Not obviously to me. Oh, this is obvious. 3 blues there, that's orange. And that's the only orange in this cage. So those are blue, that orange has to get out. Now this bit of land is going to get to the rest of the land through one of the cells of that 2 cage. And 23 is a big old total, isn't it? If this is a, oh, that's it. This is a 1 and that's 9, 8, 7. Sorry, that's very plain and I wasn't seeing it. And that is going to inform this cell, 2 there, 3 there. These are now 6 and 8 to get us up to 23 in the blue bits of this cage. And now we can do a 7, 9 pair and an 8 there, and that is more Sudoku. Now this digit is 3, 4, 5 or 9 by Sudoku. So these add up to, well, it can't be 9 as the hot digit, or the negatives would have to add to 17, and we couldn't get there. So it's 3, 4 or 5. If it's 3, these add up to 11. Oh, look what this can be. It can't be 9, 7, 8, 3 or 6. 1, 2, 4 or 5. And these two add up to 11, 12 or 13. Well, that's not a 1 then. The difference between the two digits in the -2 cage is 2. And we can't use 9, 8, 7, 6 or 3. So we're choosing from 1, 2, 4, 5. And the only pair with a difference of 2 is 2, 4 there. Pretty sure that's right. So that is a 2, 4 pair. With the 2 there tells us which way round they go. The negativity of the cage tells us that the bigger digit is negative. And we know where the land gets out of this area. It's got to go to there. We've got a 2 by 2 to avoid. And this is now a 5 by Sudoku, sort of. That's a 1. This is not 5 because it's in the same cage. This is going to have 2 possibilities. These add up to either 11 or 12. So this is 6 or 7. We've had a 6 in the box. So that's 7. That's 4. This is a naked 9. It sees 1, 2, 4, 7, 8 in the column, 3 in the row, 5, 6 in the box. That's where 3 goes in the column, and this is a 5, 6 pair. And now we've got some triples for the column of C in column 9, I guess. Oh, this is nice. I like the way this unfolds. It's very, very neat. Right. This digit by Sudoku is 1, 5 or 8. Now, it certainly can't be 8 on the thermo in that position. Can it be 5? No, because the only higher digits than 5 we can put in this box are 7 and 8. So that's a 1. This one is also a thermo bulb, and I reckon it's 2, 3 or 5 by Sudoku. I don't think I can rule on that, sadly. 4, 7, 6, 9, 1, 5. That's 2, 3 or 8. Never afraid to pencil mark. Okay, this pair has a difference of 2 for the same reason as the other 2-cell cage. But, oh no, there's a lot. It can't be 9, they can't be a 9, 8 or 6 in this. It's not that helpful. Maybe the thermo. One, 2, 3. This is 4, 5, 7 or 8. No, I don't think the thermo's doing much. Ooh, Sudoku on 1s. There's a 1 in one of those 2 positions. If it was there, that's a 3, and the 3 would be positive. And that would be positive and become a 2. Looks like it might work. Okay, this 20 cage, it's not quite as big as a 23, but its positive digit is no more than 4. And it can't be 1 because we've had a 1 in the box. Its positive digit is 2, 3 or 4. And its negatives, again, add up to at least 22. So 9 is in the cage, which is quite interesting because that's a sort of virtual X-wing on 9s. There's a 9 in one of those 2 and a 9 in one of those 2, so the 9 in row 7 is in one of those 2 cells. I don't quite know where I should be looking next. That's pretty obvious, isn't it? Oh, there's a 5 in one of those 2 by Sudoku because of that 5. So that can't be a 5. Can I rule out this being a 4 yet? No, probably not. Probably wouldn't help if I could. Okay, let's come back down here. So we're putting a 9 in this cage. I don't know. Maybe we go back to the 5 cell in the corner. Oh, 18 is a big positive number. positives have been... That could be all 4 positive. Could it be... It can't be just 2. At least 3 of these are positive. Yeah, I don't know. Sorry, I do not know what to do next. 3198. This can't be 2 because of its position on the thermo. So 4, 5, 6 or 7. Well, okay, this can't be 1, can it? That couldn't be 3. Oh, I see. So we've placed 1 in this central box, and I just hadn't realised. It's there. Now, does that help with this -2 cage? I don't think it does much. Well, okay, it does something. It tells me that the parity difference between these 2 digits, if the one was a negative, the parity difference here is odd. Sorry, the difference between these 2 is odd. This is not useful. Never mind. Never mind that. Ruminating about nonsense. Right, 4, 5, 6 or 7 here, and this is 2 digits away from that. And it can't be 1, 6, 9 or 5 or 8. Okay, so the possibilities are 2, 3, 4 and 7. So this could go 2, 4, 3, 5, 4, 6 or 7, 5. That's really annoyingly keeping all the possibilities in play. Oh, that can't be a 6. Hang on. So now this can't be a 4. So some of the possibilities are going out of play. This is either 2 negative, 4 positive. This can't be a... Hang on. What have I just taken out? No, it's right. This can't be a 7 because that can't be a 5 because of the 5 up there. Yeah, okay. This is 4 or 5. That's going to have an effect on this cell, but hang on. First of all, it must take out one of these. Oh, no, it doesn't. 5 could go with 7 or 3, and 4 could go with 2. This cell, though, is now... Well, it's less than 5, and it's not 3 or 4 or 1. That's a 2. Oh, it's just doable here. That's not a 2. I still don't know which way round these... Oh, you know, this is now not a 4. It has to be odd. That's a 5. But I don't know which colour it is. That's so strange. Because it goes with either 3 or 7. This is not a 4, obviously, now. 6, 9, 5, 2, 1. That is 3 or 8. And this is the only place left for 4 in the box. 5 must be in one of these 2 cells. That's actually been available for a bit. This... 6, 7 or 8. Ah, this can't be 9 because 9's in the box. So it's on the thermo, this digit is somewhere between 3 and 7, and 3, 4, 5 are ruled out. So that's 6 or 7. That's higher. The 6 or 7 can't be the low digit, which is 2, 3 or 4. Sorry, it can't be the positive digit, so it's a negative 6 or 7. It's the positive that is 2, 3 or 4, if I remember correctly, and therefore also can't be in this cell because that C's 2, 3 and 4. So that's negative. This is negative because if this is the side with a positive digit in, that's positive and we only have 1 run. That's negative. I mean, this is positive to avoid a 2 by 2 now. I know I'm probably doing things a bit slower than you would like at this point, but there may be something I should be looking at that would make much faster progress. 5, 9, 8, 6, but you know, I can only follow the tracks my mind will let me on at the moment. That's not a 3 now, that's 2 or 8. Now, 7 or 8 having gone there means the low orange digit here is not 4, because that would require 9, 8, 7 as its negatives. So the low digit here is 2 or 3. Oh, and 4 is not in the cage, so 4 goes there. And here we have a 2 or a 3. If we have a 3, the negatives are 6, 8, 9. If we have a 2, the negatives add up to 22. That's too much to think about. Right, let's think about this cage. This can't be a 9 anymore because you couldn't make up the sum. So that's a 9. That's not 4. We've got 5, 6, 7, and 8 left to place in the row. Now, this cage, 7 would work there if the 7 was negative and the 1, 4 was positive. In fact, this digit has to be odd. Yeah, it does. Otherwise, you wouldn't get an even sum. So can it be 5? Yes, it can. If 5 and 1 were negative and 4 was positive, that would work. Otherwise, 7 is negative and 1 and 4 are positive. So I think 4's always positive, if I remembered my two sequences right there. Okay. Five, 6. And now on this thermo, 5, 6, 7, or 8 there makes that 6, 7, or 8. But this one, yes, it's higher than 6, and yet it can't be 5, 9, 8, or 6. That is a 7. This is a 6. They're the same colour because there's no jump there. In fact, they're the same colour as this, which becomes a 5. Everything's getting filled in. Now, we can't put an 8 in this cage. So 2 is the low digit. 9, 7, 6 are the high negative digits. It's a 2, 7, 9, 6 cage. 2 is the orange. 2, 7, 9, 6. So then we have 3 and 5 to put in these other two cells. I don't think the thermo's resolving those, but we get 8 there. Now we've finished box 5 and lots of box 2. 5, 6, 8. This is a 2, 9 pair now, and that is a 6, 7 pair. Let's get rid of the corner marks. Okay, good. Now I've got to think a bit more about yin-yang. Oh no, maybe this. And these are all the same colour. I haven't been thinking about the colouring for a little while. Oh, this whole thermo can't be the same colour, or it would shut in cells of the other colour or create 2 by 2s. So there is a change in colour along the thermo. And what does that mean for the lower cells on the thermo? It means something. These are all the same colour. Let's make them a bright green for now. I don't know whether that's blue or purple. I know that because they don't jump. Oh, that 7 has made this a 1, and in fact sorted out that triple on the right. Oh, okay, this is going to give us triples here, and we might be able to do some calculations in the 13 cage. Oh, I can write in 9 and 3 here. Don't need to know the colours yet. Now, in this 13 cage, the total sum of all the possible digits is 1, 2, 4, 5, 8. They add up to 20. That's not a huge number. So 8 has to be in the cage. Otherwise, the total sum of all the digits would be 12. So that's not an 8. So 8's in the cage, along with 2 and 4. So if you paired them up with a 1, that would add up to 15, which is 2 higher than 13. Now, you take off the same number twice, once to stop it being positive and once to make it negative. So we divide that remainder of 2 by 2 and we get 1. So if this is 8, 4, 2, 1, the 1 is negative. If instead this is 8, 4, 2, 5, the total is 19, The negative digit would have to be a 3, and that's not possible. So this is 8, 4, 2, 1. And that's a 5. And the negative digit is a 1. And those 2 and 4 are therefore positive. No, sorry, the odd one out is a 1. And in this case, that's positive because we're looking for a negative total. So the 2 and 4 are both negative. Now, does that... Maybe that does tell me what colour 7, 6, 5 are, but I'm not sure how. One of these is a positive 1 and one is a negative 8. Oh, the 5 and 3 here. The 5 is positive and the 3 is negative. That's just been given away. And now we've got this 7 here. The 7 is negative and the 4 and 1 are positive, and that makes the sum work. In the 20 cage, it's going to be the 2 that is positive. Now, we mustn't have a checkerboard here, so that's orange. Then we mustn't have a 2 by 2, so that's blue. Now, I need to try and see the grid holistically in some way. Tricky, I can't quite do that. 5, 6, 8, that's a 2, 9 pair. There's no jump on this thermo. That's blue. Is that meant to be telling me which way round this goes? Oh, what is making up the 5 cage? Oh, you muppet. One side is 2 blues, so there's only one positive. That's by the original rules. The positive is 8 or 9, and it can't be 9. The positive is 8. There it is. The negatives are a 1, 2 pair. And that's been so obvious for a long time. Anyway, got it done. I think I might be finishing off now. I honestly do. 6, 7. The 2 was the odd one out, positive. The rest of this row is now negative by the rule. Now, this is not a 2 by Sudoku. 7 and 5, they haven't sorted these out. 5, 7, 3, 9, 8. That is a naked 2 in the column. That's a naked 6. Then that's 1, and then we get a 4 here. That's just right in stuff. 1, 2, 9, 6, 7, 8. 3 or 4 there. That's a 6. That's not a 6, that's a 6. That's all very clear. They're not 2s, so the 2's in the corner. That's not a 6. 5, 8, 7 to go. That's a 7. That's a 5, 8 pair, so that's a 6. 1, 3, 8. Now, we might have to do some work thinking about this cage in a moment. That's a 9. That's not a 2. We've done that. We've got... That sorts out 3 and 4, which does all these numbers at the bottom. Now, we've got jumps, so that doesn't tell us any more, but surely I must know whether this is... This orange has to get out, but it could get out... No, it can't. These can't all be orange, because that would shut in some blue or create 2 by 2s. So they've gone blue. The orange now does have to get out. There, that's orange to avoid 2 by 2. Actually, so's that, and that orange has to get out. We've still got to get out from the bottom of the grid in orange, so that goes orange. That's not a 3. We've got 1, 8, 4, 6, 7, 2, 9, 1. That's 3, 5, or 8 by Sudoku. Okay, so now this cage. The possible digits add up to 1923. So we can't lose the 8 out of the cage. We must have an 8 in the cage. In fact, I think 8 and 6 must be positive. They add up to 14 then. If the 6 was negative, the other digits would have to add to 24. I don't know that there's a negative digit. In fact, that's worth thinking. 8, 6, 3, 1 could all be positive, or 8, 6, 5 positive and 1 negative. Oh, that's confusing. So I'm not done. Bother. One of those is a 5. One of those is a 5. How am I meant to do this? Right. Well, one way round it must work, and the other way around it must not, which is going to take some thinking about. So if it's 3 positives, oh, maybe let's think about this digit. If that was an 8, that's an 8. And this is 3 and 1, and they're all positive then. And that would have to be positive once that was negative. If that was a 3, though, this would be a 1-8 pair. And that would be a 5. And the 1 would be negative, but there's a negative 1 here as well. No, it's a positive 1 in this box. Oh, this is getting my head mixed up now. There is a way to do this simply, I'm sure. Let's think about this again. If that's an 8, these go positive, 8 and 6. In fact, these are always positive. It's either 1 or nothing that's negative. So they're definitely always positive. So that's blue. This mustn't be a checkerboard, so that's orange. 1 or a 3 may be negative. This one, I don't know. These are all blue because the perimeter only has 1 change. So that's orange. That's orange to avoid a 2 by 2. And therefore that is the 1. Yes, that's right. That's 8. That's blue. That's now 8. Surely we can actually just finish the numbers now. We can. This is 3 and 1, and then we just add up the last couple of digits. Oh, sorry, that's correct. Now we just need to colour this. 5, 6, 8 is 19. They're all orange. That's blue, and this one is orange to connect, and there is the finish. Wow, what an incredible peninsula we've created. Very odd shape of it, and we are pining for those fjords, which is what it looks like now. Brilliant, great stuff from Truffle Bear. See you later. Thanks for watching. Bye for now.